Greetings to you, ladies and gentlemen, and welcome to Waffle TV. This is a platform where we demystify, we exemplify, and we simplify elementary mathematics for your understanding. For the past 1 year, we have been doing a great job as far as laying the foundation in elementary mathematics is concerned. If you have missed all what we have been doing, there is hope because all is found in our official channel, Waffle TV. Subscribe so that you will never miss any lesson, as we always share a minimum of 2 videos each week. In addition to teaching elementary mathematics, we equally engage in environmental protection and equally saving humanity through volunteerism and other welfare services like support to the physically challenged and the orphans in local communities. Through this, we are going to invite you to join us in our initiative for this year, where we intend to support children in their education in local communities for 2023-2024 academic year. To know more about this, you can visit our website at www.wapfu.com. Here you are going to see the vast majority of things that we do, and of course identify which you can associate yourself with and how you can collaborate with us so that we serve humanity better. With this said, last time we talked about the various aspects of rates, and we promised you that in today's lesson we are going to start with ratios. We have 3 practical lessons in ratios, and the first being how to simplify and compare ratios. With this said, in today's lesson, our target is to be able to define, to simplify, and to compare ratios. So, with this in mind, we can go straight into our lesson to see how we can apply some examples, solve some examples to better understand what exactly ratios are. But before we go into that, there are some key facts that we want to take note of first before we go into the real matter. And these facts are, we have to note that ratios express relationship between quantities or among quantities, because you may have more than 2. So the relationship that exists between these quantities is what we call ratios. Another very key important fact is that ratios show the number of times one contains in another. That is, the number of times one quantity is contained in another quantity. And the last thing we have to take note of is that the mathematical symbol for ratio is a column, and this is read as is 2, or you can just read it as 2, and as well as this column can also serve as division. We shall see more of this in the examples that we have to solve for today. Our first subheading here is expressing a ratio in its lowest term. For you to be able to simplify or express a ratio in its lowest term, the first thing you have to take note of is that divide the quantities that is given by their HCF. If you miss a lesson on HCF, you can scroll back to check on our lessons on highest common factor. And also, if it's the case of fractions, because sometimes these ratios are expressed in the form of fractions. If you have fractions, then multiply each fraction by its LCM. LCM is the lowest common multiple. And if you missed a lesson on this lowest common multiple, you can equally check back at our last or previous lessons to find LCM or HCF to refresh your memory on it. Let us now solve some practical examples and see how exactly we can find or simplify a ratio in its lowest term. Here is our first example to simplify 4:10 to the lowest term. As we have mentioned here, it says divide the quantities by the highest common factor. What will be the highest common factor of 4 and 10? We all know this is 2. So if you divide 4 by 2, you have 2. And if you divide 10 by 2, you have 5. And our answer will be 2:5. This is just what you are supposed to do as far as simplifying a given quantity or a ratio to its lowest term. This is not all. Let's look at some other examples to see what you're supposed to do as far as this is concerned. Our next question is a fraction. 1/5 is to 2/3 to its lowest term. What we are supposed to do in the case of fraction is multiply each fraction by their lowest common multiple. So the first thing we have to do here is to find a lowest common multiple of 5 and 3, and that is 15. So we're going to take 1/5 and multiply by 15 is to, you take 2/3 and multiply by 15. And here we can simplify. 5 here one time, 5 into 15 3 times. 3 here one time, 3 into 15 5 times. And 1 times 3 is 3, and 2 times 5 will give us 10. So our answer in this case is going to be 3:10. Let's move on to find out how we can also interpret other questions and simplify as far as simplification of ratios is concerned. If you look at the third example, it says 35 centimeters is to 1 meter. Now, something comes to mind. When you look at this carefully, you realize that the units are different. All may be measuring length, but they are different because this is in centimeters and this is in meters. So what we do is we convert all to one single unit, then we simplify where necessary. So in this case, we are going to have 35 centimeters is to, we convert 1 meter to centimeters, and this will give us 100 centimeters. Here they are the same, and we can now simplify by dividing by the highest common factor. 5 can go into 35 7 times, and 5 can go into 100 20 times, so that our answer will be equal to 7 centimeters is to 20 centimeters. So this is what you can do in this case. Take note, you change the unit to centimeters, then simplify and have your answer here in the lowest term possible. Now let's look at the last example as far as this is concerned before we move to comparing ratios. Let's listen to the question very keenly so that we don't miss out on something. Peter saves $50 and Mary saves $20 more. What is the ratio of their savings? So what we are supposed to do here is first to identify what Peter saves, $50. Then we identify what Mary, Emma, saves, $20 more, which means she saves $50 plus $20, and that is equal to $70. Therefore, ratio will be equal to 50 is to 70. And here, their highest common factor is 10. 10 will go into 50 5 times and into 70 7 times. So that the ratio will be equal to 5 is to 7. If this is understood, then we can move on to comparing the different ratios. For you to be able to compare ratios, the first thing to do is express each ratio as a fraction of a common denominator, then compare the numerators. Another way in which you can equally compare ratios is you can change the various ratios into decimals and compare these decimals. Let us look at some examples on how to do this practically, and you will better understand what to do as far as comparing ratios is concerned. Now we have our first example. Which is greater? Is it 4:5 or 7:8? What we are supposed to do here is simple. You express 4:5 as a fraction, that is 4/5. Then here 7/8. With a common denominator, you find the LCM of 5 and 8, which is 40. 40 divided by 5 is 8, and 8 times 4 is 32. 40 divided by 8 is 5, and 5 times 7 is 35. If you compare these two numbers, you realize that 35 is greater, and 35 here represents this fraction, and this fraction represents this ratio, 7:8. Therefore, 7:8 is greater. So this is what you can do as far as this is concerned to find out which is greater. Let's look at the second example, and of course, this will take us to the second method through which you can compare different ratios. Compare 2:3 and 1:2. In this case, we are going to change these ratios into decimals. Then we compare the decimals to find out which is greater. So let's start with 2/3 or 2:3. 2:3 is the same as 2/3, and 2/3 means 2 divided by 3. It cannot. So we're going to fix a decimal point and affix a 0 behind 2. And 20 divided by 3 is going to give us 6. 6 times 3 is going to give 18. If you subtract, the difference will be 2. 2 cannot divide because it's less than 3. And since a decimal point already exists, we just affix another 0. It becomes 20. 20 divide 3 6 times. And 6 times 3 is 18. The difference will be 2. And this will continue to infinity. So we will stop here for now and change this as well to a decimal. 1:2 is the same as 1/2. And 1/2 means 1 divided by 2. 1 cannot divide 2 because it's less. So we affix a 0 here and put it our decimal point. Then when we affix the decimal point, we can affix a 0 as well here. 10 divided by 2 is 5 times, and 5 times 2 is 10. If you find the difference is 0, and so our answer at this level is 0.5. While this way, our answer is 0.666. At this level, we can compare these two fractions to see which one is bigger or greater. We start with the first digits. Here 0, here 0. It means at this level, they are the same. We move to the next after the decimal point. Here is 6, here is 5. At this point, you realize that 6 is already more, and for that reason, this is greater. Therefore, 2:3 is greater. You can use the decimal method or this other method to compare and find out which ratio is greater. If you've learned something, consider giving us a thumbs up, subscribe to our channel, and equally share your thoughts in the comment section by telling us what we may improve. In our next lesson, we are going to be looking at how to increase or decrease quantities in a given ratio. And until next time, it is goodbye from us.